Hello, welcome to the Easy Access 1 Project J1A Chapter 2. Project J1A is to build a feature-rich multi-threaded Java-based email proxy filter from scratch. We're at Chapter 2, and we are going to start talking about socket communications. In order for us to effectively do Java socket communications, we're going to have to load two packages, java.net star and Java IO star. I will explain how loading works and when we'll load them. Secondly, we'll create a socket object and we will choose a port. Then we will go over the types of strategies to extract information out of the socket object. And finally, we will begin a brief discussion of SMTP over TCP, which rides over IP. All right, we're back in Eclipse. You'll notice, as a slight review, we have the loader class and we have the proxy controller class created. So now we are going to have to import java.net.star. And you will find that if you're doing socket communications, you're either going to have to write your own class or you're going to have to import the ones that come from Oracle Sun, which is probably a good idea. Okay, now that we have a socket in the mix here, I'm going to create a private integer called my Java listen port. And why don't we just call that SMTP listen port 25. Huge surprise for anyone who knows anything about SMTP. And there's also a possibility of serving on port 587. Right now I'm going to set this up for loopback, which is going to be no parameters. Private int. You could even do a private static int if you wanted to, like that. Final. Let's get our socket object going. And we're going to try catch loop already. So our server socket called server is equal to null. So it now exists. Okay. Let me steal this. I'll explain what I'm doing here. Server socket is defined. Server creates a new server socket. You could do this all in one line, like that, if you wanted. See how that works? I'm going to create an access point to a new method called conversation manager, combo manager, and the object will be passed, will be the server socket. Also take a moment, you see I've added these two comments here. I'm going to generally address this thing that's annoyed me about Java programming for about 20 years. I'll do a lot of code, and at the end of virtually every batch of code, we have this little congregation of brackets. And some of our favorite editors in the world, this one isn't, yep, it is doing it. It's kind of highlighting. See how I click on this one bracket kind of, and it kind of highlighted this other bracket. And if I do this one, see how it highlights this bracket? That's very nice. If you get into Notepad, if you get into Visual, if you get into anything Linux, that stuff is all out the window. So I like to occasionally put a comment. This is EC end catch, EM end method, EC end class. And now at least I know what those brackets are. You start copying and pasting code, and you're going to lose track of what goes where. And if you're working with a command line compiler, and you go to compile and you've got one bracket or one bracket too little, one bracket too many, it is pure hell trying to figure out what's going on, because that stack trace or the compile time error, it'll tell you that the error is on a different line than the error really is, which is understandable. So, okay, went over that. Now I went right down to my EM. As you know, that's the end of my method. Public conversation manager socket server. And it's going to be a void. Combo manager. And that's getting upset because I'm passing server socket. Okay. So now I have another method which I'm going to do my logic for my socket work. You might be asking, how come I'm making a new method? Later on, I'm going to thread this out, and I'm going to start creating a thread for every connection that comes in to the SMTP. So I don't really want to trash my main method with that. I would rather keep a method that just forks creates the multi-threading, and I'm going to creating some thread objects, and then I'll toss them out and I'll parameterize the socket, server socket, and any other parameters that need to go so I can do any logging. And you'll explain later. I'm actually going to change the name of this method later to something else, but for right now I'll call it a conversation manager, combo manager. So we know that anything that happens in here is going to have to be in a try-catch loop. So let's just get that pasted, and we'll borrow the one from above, and then we'll end the method. And let me get rid of that for the moment and make sure we pass compiler. And every so often I like to click on the run button to make sure that we pass. And the console's empty. We don't do anything yet. We do create this server socket just for a moment, which then dies. So we have this new method, this little gem, and I'm going to add the fact that I'm now in a new module, or a method, but this .module just became conversation manager. So now, when the system.out fires an exception, the exception gets caught, and now I am in the correct module in case I have a failure. Okay, now I'm going to start off with something very simple, very simple. And for those of you who started life in a telnet session, I started my computer life in 1994, I think it was 95, and I was working in a telnet session, and that's all I had. I didn't have a browser. We had something called Trumpet WinSock, and the telnet session was part of a weird get onto the internet dialogue that my ISPs provided, and everything was pretty much ended with the enter key. Your whole life depended on the enter key. If you forgot the enter key, nothing happened. So a lot of the basic socket communication relies on something called character code 13. And you younger generation aren't going to have any idea what character codes really are. But there was character code 10 and 13, and there's this war going on the internet between character code 13, character code 1013, 1310, CRLF, and Visual Basic, what have you, /R, /N, you don't remember any of this stuff, \. You'll be using all this stuff. The original conversations on the internet were terminated with character code 13. So it's kind of like the enter key. So in a chat session, the enter key would kind of end your line. So keep that in mind as I start to create these next few lines of code, because we're going to start transferring data between two processes, which is what socketed communication really is. And in order for us to have a conversation, we have to have the end of each thought, or the end of each line. And in Java, or not necessarily in Java, but in the socketed communication in this simplistic way, we'll use character code 13 as the end of our line. And that is actually built in to some of the pre-made products that exist inside Java already, which I'll show you just in a second. I'm going to create an object called an input stream. Input stream is kind of a subclass or a part of the socket and actually server. And in order to use input stream, I have to load a package called java.input-output, java.io. And sorry about that. Had to go back and check out why I was getting that error. Doing all of this from memory. I'm going to create, let's reiterate over the top of this. Server socket server is created by this constructor, server socket. And there's a method that fires when a socket is accepted, creates an actual instance of socket. Okay, and combo manager, no wonder I was having a issue with this earlier. I'm going to create that S there. Okay, so server socket server is created here. Your actual socket object is created when server accepts a connection. So it actually will hang here. Then I'm going to create a method called combo manager. Combo manager accepts the parameterized object S. I set the module. And now I'm going to grab, sorry about that folks, the input stream object from the socket object. Okay. Next, I'm going to create the input stream reader. This is some prepackaged stuff. I won't be using this later. I'm going to do this so that the kind of basic understanding of socketed communication can take place. And we'll enhance this and use it as something else. And the reason being is that the kind of communications that client input stream reader and buffered reader we'll be using in a second, the buffering in the input stream reader will be depending on carriage returns, carriage code 13, and it's dependent on some basic assumptions that someone's going to type a message and hit enter. And the kind of communications that I do or you'll be doing, there's no concept of enter in some of the things that we're going to be doing. So it's very nice and all. It's good for demonstration purposes. So I'll load these objects so that we can demonstrate the functionality. So I'm going to create this input stream reader. Then it needs to be managed. It's going to be managed by this buffered reader. And the buffered reader is created by passing the input stream reader. And now we're going to get actually down to the string that's going to get taught, typed. Buffered reader, I'm going to read line. Now anytime you get into, if any of you guys out there have been to college for this, I mean I remember C++ in college on that green screen, and we were doing standard in, standard out, and standard in, standard out, especially standard in, it was all about the carriage return. And when you read lines, and you read, but especially read line, the concept of a line is a little ambiguous to me. But in programming, line is kind of an array of characters with a character code 13 at the end. So keep that in mind that there really is no real line. You can't define an object as a line, or maybe somebody has an object called line out there. I don't think Java has one. So you can't line L equals new line parenthesis. There's nothing like that. So this read line thing roughly translates into a string object. You could probably overload it or transmute it into something else. But for right now, we're going to be pulling a line from the buffered reader, which pulls from the input stream reader, which pulls from the input stream, which pulls from the socket. So that being said, it's going to sit there until something happens. And when something happens, the message is not going to be equal to null anymore. And if we get to this point, it's probably not equal to null already, but hey, why not? And let me end if. See how EI, end if. Okay. So now what I'm going to do is I'm going to pull the message that is not equal to null. And if the message comes in, that means that the string object will now have the message, which is the line which is pulled out of the buffered reader. Then I'm going to create a print stream object. Okay, here's where you got to kind of watch what's going on. I'm creating the print stream object by getting the output stream of the socket. And then I'm going to push the words received to the print stream. And then at the end of this, I'm going to, might as well just, I got to do something with this message, so I will just simply push it out. Message was message. Okay, that's simple enough, isn't it? All right, so we're ready to run this. If anyone wants to guess ahead of time, now's your time to guess what I'm going to do. In order to do this test, I'm going to need something to open the socket. So my favorite is to use the telnet prompt, which I had to specifically install on Windows 7 because for whatever reason they don't actually package it with the default install. But I'll run. We're going to load the loader. We're going to load the proxy controller. The proxy controller is going to create a server socket. And the server socket, right now we're stuck right here. It's waiting on the accept. So it's this kind of a very interesting little piece of Java that I haven't defined any sort of threading at this point. I haven't called system sleep, the thread sleep or any. I haven't manipulated the system clock at all. I haven't specifically told the system to wait here. Some other layer of programming is creating the server socket object and the socket object from the server socket. And that's done right here. So we're sitting here at accept. The minute someone connects, I'm going to call the combo manager and pass that socket object to it. Okay? And when that happens, this event, this method will fire. And I will bring up a command prompt right here. And I'm going to telnet localhost and port 25, which should be open. And you can see by the blinking cursor in the upper left, it is open. And from what I can tell, we will stay here infinitely, waiting for something to happen. So I'm going to type the words hello world. Enter. Okay. So what just happened here? I connected, and when I connected, we went into this conversation combo module. The input stream was created. The input reader was created using the input stream. The buffered reader was created. The buffered reader is the object, the prepackaged object from Sun that has a predefined way of pulling information based on a carriage return. And if you notice when I slammed the enter key pretty good, that's what the carriage return was. So when we sat here at br.readline, we were again stuck. When I said that we'll be here forever, we were at this line right here. And the programming simply just halted at that point. These are kind of weird things that happen in these programming languages. But here they are. So I typed a message called hello world, and then as soon as I hit enter, the hello world was read into the string message. Message was not equal to null, obviously. I created a print stream object and grabbed the output stream of the socket, and I pushed the word received back, and since I used print line, the Java system added the carriage return to my statement. So you'll see received on the telnet session, and then I overload. All right, I pushed the system out the message, and the message was hello world, and you can see it. It came into my center console. So this is great and all for a single bit of communication, but it's not much for long-term two-way communication via chat or something like that. So I'm going to do a quick redesign here and throw a while loop and change the way that my strings are constructed. The first thing I'm going to do is define my string as a message as an empty string, and then I'm going to create a while loop, while message equals stop, and then I'm going to say, well, it's not equal to stop. That exclamation mark right there reverses the polarity of the true false. So inside this while loop, I'm going to have message equal buffered reader read line. Okay, and I'll push these in an indent. And then I'll change this just a little bit to say I've received your message, and I'm going to have the system out tell you what the message was here. And I'll say it here. Actually, I already had it there once, so I'll just change that. Okay, and now at the end, my while loop EW, and that should pass the compiler. Okay, just like that. And that catch should be here, like that. Okay. So I'm sure most of you have figured out at this point in time I'm creating a two-way conversation. So I've created the possibility of giving the client a level of control. So now my string is defined outside the while loop, and currently the string is going to be equal to nothing, so it's going to make it into the while loop. Then the message is going to be assigned, and I will give it some random characters or maybe a word, hit enter. Then if the message is good, or the message is not equal to nothing, null, then I will tell the client that I've received your message. And then I will locally here in this console print out what was typed, and then I will loop back waiting to see if the command was, the text was stop. If the text was not stop, then why don't we make it exit? I'll leave it stop right now. Exit's much more command prompty. So we'll have a loop going here where the buffered reader will be pulling down lines as they're typed until such time as we're stopping. We're stopping here. Okay. I will telnet in. Start this. Make sure we go past the compiler. Running. Connect on port 25. I'm connected. And I'm going to say hello, Dolly. The information's been received. The system out was told about the print line, about the hello Dolly command, but you'll notice that the program hasn't terminated. See, this red mark here still means that we're still, I can terminate this JVM, this Java W, so it's still running. So we've looped back up to the read line, and I could type again something, the next thing, and you can see here the next thing. Local echo is turned on in this telnet client, so the message was the next thing, and Star Trek Star Trek, and some backspace characters that I hit. Okay, so now I'm typing letters, they're being received, I'm putting them out to standard out, and we're waiting for the next piece of information to show up. And now I'm going to issue the command stop, or I'm going to try to stop, and then the while loop is going to realize that the message is now equal to stop. That's going to break us out of the while loop, and we're going to tell them, hey, we're stopping. And here's, you can see that the command out, the console, the standard out, knows about the program being terminated. And one other thing you can do is you can actually move this up here and then take it out of here. So that's just a little cleaner. That's up to you. And one other tip, and I just did this wrong. If you're going to check your objects for being null, and if you're going to incorporate an if or a while or do any of these do loops, you actually have to do the null checking first. So believe it or not, this line will not be evaluated at the same moment in time. So if this is equal to null, it won't worry about the stop. It's actually going to do a left to right check. So if it tries to see to do a string comparison and this message happens to be equal to null, then you'll end up with an error and you'll break out of your try catch loop. But if you pull the null, if you put the null check in front, then you're going to be in much better shape and you're probably going to get the appropriate result. Okay, I found that in my many travels of doing socketed communication that these buffered readers are only really good for moving around text files. They're only really good for pre-formatted text. They're not going to work very well with control characters. Matter of fact, they're guaranteed not to work well with control characters. When I say control character, I mean any character that isn't really easily typed on a keyboard without using the Alt button. So a backspace, a Control C, a Control J, a Control M, whatever's going on. Or maybe you're using the full 256 character set to transmit data. Maybe you've created your own language. Maybe you're using a base, something in another base 128 or something like that, base 64. This concept of using the buffered reader and using the input stream reader, it's not going to work for you. You might get away with it in some instances. I found that unless you're writing bulletproof code, sooner or later something's going to come along and it's going to mess your code up. So you're going to have to come up with ways of dealing with every possible character that you might have to deal with. And the only way I found to deal with that in Java is to use the byte, B-Y-T-E, byte array. And the byte array is going to be an integer embodiment of all 256 possible characters that or 128, depending how you use your sign, your positive and negatives, your little Indian. So when I create these socket objects, I use byte arrays, and they're significantly harder to do because I'm not going to use any prepackaged stuff. But you'll see in the future that sooner or later you're going to get sent a control character in the middle of a sentence, in the middle of a message, or a control J or a control M. Something's going to happen that's going to break buffered reader.readline, and it's going to happen probably in the first couple milliseconds of any significant product or project. So I'll get into that. Unfortunately, I'm going to be deleting virtually all this work, but I thought it was good to go through the concept of kind of the kindergarten version of dealing with the socket before we get into anything complicated. Okay, so I'm going to get rid of this whole while loop, while brackets, get rid of this message. String as a message is a bad idea. Buffered readers is for maybe 5th, 6th grade Java. Input stream readers, nice. I'm stuck with the input stream and the socket in order to do anything functional. So the first thing I'm going to get into is this concept of a timeout. If you get away from the buffered reader, and buffered reader is one of the few classes that does provide connection state management. For whatever reason, by default, TCP/IP really isn't very good at telling you if the guy at the other end is still talking to you. There are ways to do it, but generally speaking, we use timeouts. So I have for this project, I'm perfectly fine with using a 20-second timeout, which would be 20,000 milliseconds. So I'm going to define a long called timeout at 20,000 milliseconds. And I'm going to create a heartbeat object, which gets the current time in milliseconds. Now, you don't need to know what this number is. Suffice to say, it's a very large number. It's actually the number since 1971 or so, 1970, since the epoch. And what we're going to do by using the heartbeat and the timeout is we're going to figure out how long it's been since there's been any communication. So this is going to serve a dual purpose. First, it's going to be a good tool for me to make sure that I don't have an open socket that goes to no one who's not really reporting in or has disappeared off the internet. And second of all, you can have problems with the client. The client can get himself into a situation where he just sits there and he ties up one of the sockets on of the server stack, and he could essentially, you can take down a server just by locking up sockets. So this is a good way to prevent attacks, or at least mediate some attacks, because one of the early ways of taking down a mail server was just simply keep connecting to it and keep creating sockets until the end of time, and wouldn't take too long before all the sockets would run on the computer. Even it's only a 16-bit integer, so what are you going to do? 2 to the 16th power, what is that, 65,000 or 32,000? 65,535 sockets are available. So it isn't going to take you very long before you're going to run out of sockets, and then the system becomes unavailable. So it's a good way to manage our connection. So I'm going to add a line here that tells me that a port has been opened at a certain time. Okay. Now we'll get into something interesting. I'm going to create a byte object. Now this is a Java object called bytes primitive, so I'm not creating any. It's not an object; it's a primitive, so I don't need to create a new and throw so much parameters at it. There may be a capital B byte object used later. There is the byte object, but it really doesn't have any use for me right here. I will have what's received, and then I'm going to create something called the message object. Now the message object is going to be a concatenation. So the concatenation is where I'm going to start pushing all the bytes into the object that I'm going to create the message with. So I'm going to concatenate all the received bytes into a message array. Message byte array for messages, and I'll do that with a system array copy. There's a whole bunch of ways you can do it. I like to use the system array copy. It's done at the system level, so hopefully it's a little more optimized. It doesn't sound like a real grand tool, but when it comes to pushing these data arrays around, if you get away from the byte class, there might be some cleaner methods out there, but this way you're pushing the accurate information and you're not going to be convoluting. For instance, if you saw previously, if I would have mistyped anything in that telnet session and hit the backspace, and then what came out is not really a good result if you put those little blocky characters in there. So now we have our received. It's kind of like a little buffer, and then I'm going to have our message. And then I'm going to start a while loop. Now here's things are going to get a little complicated, and I'm going to need you to really hold on to your hats here. While the current system time minus the heartbeat is less than timeout. Okay? Now this is probably the first time in this entire tutorial we've done anything that's going to throw you for a loop. This is basically saying, as long as the system has heard from you in 20 seconds, we will continue this conversation. So the system time minus the heartbeat, it better be less than 20,000 milliseconds. And if it is, we will continue listening to see if there's any communication going on, any data coming in. So let's go with the client is available. Okay. Now client input stream available is greater than 0. That means that there's data, at least 1 byte of data has become available. And I'm going to get that data that's available. Received equals the new byte, client is available. Okay, so client is available, and I will get the information. Okay, sorry, I made a mistake. I'm not actually getting the data right here. Right now I am redefining the byte into the proper length, and most likely this is going to be 1. In some cases it could be any number. When we get into higher arrays, the information will, depend on the packet size, could be anything. But right now in the session what we're dealing with, this is probably going to be 1 at a time, 1 letter at a time. So now I'll pull the data read right here, and I'll pass the byte array into the read method, and the input stream reader will assign. Okay, now I'll do this. I'm running over on this lesson, 33 minutes, but I'm going to create a temporary byte array called combined, and the combined is going to be a new byte. Now, why is it doing this? There. The combined byte is going to be a new byte object, array object, the message length plus the received length. Okay, so right now the message length is going to be 0 because the message is empty. So the new byte with an array length of 0 plus the received length, which is probably 1. So I'm creating a new byte with a 1 dimension of 1, that's really simple right now. Later on this is not going to be simple, but this is very simple right now. Now, hold on to your hats. Here comes the system array copy. Now the system exposes an array copy, and I am going to copy into combined the message at the full message length. Okay? All right. Then I'm going to copy the contents of combined into the message. Okay? So we're going to combine and then push into the message. And I'll do that right here in this next line. And my temporary byte array called combined should be good to go. Okay. And cleaned up a little bit there. So I'm using the array copy to pull these bytes together and to create the message, the array of message. So it's not really a human readable thing at this point in time. It's going to be an array of bytes, which is basically an array of integer numbers. So I am going to make the statement that the heartbeat has been beat, and I'll update the heartbeat integer, or it's actually a long. So while we're in this while loop, we will be waiting for the client to be available. And if data becomes available, it'll be a single integer probably will come in what I'm going to do right now. Later on it'll be blocks. And we're going to catch those keystrokes, if you will. That data that's going to come in is going to be converted into a byte arrays, and then I'm going to combine the byte array with the known bytes, and then eventually we're going to process that and do something with it. So right now there's no real way out of this other than to wait 20 seconds. So I will add a line here called if the received information is not equal to null, which it shouldn't be if I'm here, then if the received is equal to character code 13, then break out of this while loop. So this is a real down and dirty way of replicating what we saw with the buffered reader earlier, and it's basically going to do the exact same thing on. But now I have full command of the data flow, and I'm not giving it up to the buffered reader. So in order to track what I'm doing, I'm going to add these 3 debugging lines. This was the message, and in Java I'll be able to transmute that message into a string UTF-8 and have to specifically tell it what kind of string I want sometimes to make sure that the display doesn't look funky. And the message length and breakout of loop. Okay, let's do a test. Let's run it. Pass the compiler. You can notice by this red terminate button here that the JVM is running. I'll bring up a telnet prompt, telnet into my local host. The port's been opened. Hi. Yeah. Okay. The message length was 7. And let me scroll this up. The message was Hiya. The message length was 7, and since I hit the enter key, I intercepted the enter key as the end of my message. And then I broke out of my while loop, and I have successfully recreated the buffered reader functionality here. And now I have full command over control characters or any other information that I would want to manipulate. I could alter the data as it comes through. I could fix the data as it came through. If I had incorrect characters, I could identify them if I knew what patterns to look for. There's a lot of advantages. I wouldn't do it any other way because the read line is this constant failure. Okay, let's wrap this up. We went over importing the JavaNet and the Java.io. We created the socket. We demonstrated the use of the socket listener, the server socket, the input stream, the buffered reader. Went through a simplistic way of getting communication into a socket and extracting the data. Now we talked about the concept of using a heartbeat, a number of milliseconds, to make sure that the connection is still active. And I went over using byte arrays in order to hold the information in a more containable way. I want to talk a little bit about TCP or SMTP over TCP. This is a text-based communication, and I know some people are saying to yourselves right now, well, why couldn't I just use the read line? Because that'll make my life a lot easier. I'll use the read line. And I'm telling you, I have written this program before for another customer. I know for a fact that not all email servers simply transmit text. They are out there doing wild things. There's people hacking. There's people sending all sorts of crazy characters at you. And the idea that communication will somehow stay as UTF-8 or to be UU encoded properly or base 64 is complete nonsense. Within the first 20 minutes, someone will shoot you a character that read line will fail on, or part of the read line will break, or they will send 50 megabytes of information without a control character like character code 13, and your system will have to create a string object that can hold 13 or 10 megabytes of data, and very quickly it won't work out for you. Okay. I appreciate your time. I'm sure I've made some mistakes. Feel free to subscribe and feel free to leave your comments. My name is Ben Hujan, and join me for Chapter 3 later on.